Okay, in the last video we saw how to insert different elements to different data structures, and for example, in the case of tuples it is not possible, and we also saw how to actually delete different elements wherever possible. So let's go to our friend Jupyter Notebook and see all these concepts in a running form. So let's go. Okay, so let's, for example, we have list. That's our list. Let's append an element to the list, or maybe more elements. That is L plus, let's say we can have another list, for example, how, or that's 6, and then U. That's it. And these two lists will be appended, and the new list will be as you can see, this. Similarly, we can append an item using append function. For example, 6.8. That will also be appended, and the list will contain these kind of values. So yeah, so both ways are fine. This plus is this plus can be used to append to lists, and this append function can be used to simply append a list with an element. Okay, great. Tuples, you cannot change a tuple, but what you can do is you can have two tuples. For example, T2 is a different tuple, let's say A and B, and let's say you have 45, let's say that's tuple 2. Then you can have a third tuple that is just the combination of tuple 1 and tuple 2. And in this case you have tuple 3, which is this. Yeah, so tuple 1 and tuple 2 are combined together, but you cannot actually insert into the tuple is immutable. You cannot insert another element, you cannot delete the existing element, you cannot update any element, and so on. Similarly, S, the set, let's see the state of the set. That's the set.add function. You can add anything, let's say 56, that is added there, and the new state of S is this. Or you can call the update function, if you update method, if you want to insert more elements. For example, if you have multiple elements to be inserted, 23 game, and let's say you wanted to insert an element that is already there, so for example 1, then the duplicates will no longer be there, but the new elements will be inserted. Now let's see the state of D. The state of D is this. If you want to add another key value pair, you can add a key here. For example, a key might be new key, for example, new key, and the value might be for example, a new value. And now if you see D, the contents of the D has changed. Wow, that's simple. Yeah, great. Can you concatenate two dictionaries together using a plus operator? Is it possible? Is it possible to concatenate two dictionaries together? Let's say I have another dictionary T2 that is let's say the key is Y and the value is YY, and then we have another key, let's say Z, and the value is let's say 10. Can I concatenate D and D2 together? Can I just update my D and add these values, insert these values also there? Okay, I left you with this question. You try to answer this, and in the next video I will answer this question, but try to answer this question yourself. And one way to try that is just to go in Jupyter and just type and check whether plus is working or not, or maybe there is another method and stuff like so. Okay, great, hope to see you. Oh, I have not used the del, delete, and all that stuff and so on. So this question is there. Let me use the removing the elements. So let's say L is this list, if I want to remove any element, let's say element number 3, if I want to remove element at index 3, which is this string name, I can use simply this delete, and the L is everything but without that element. Similarly, I can remove, if I want to remove any element from S, I can call the function remove, and whatever I want to remove, let's say I want to remove game, and the game will no longer be there. Great. If I want to remove some element from dictionary, again, let's say that's a view of dictionary, I can call D, and I can remove the element with key, let's say C. Whatever the element is with key C, delete that element, and the dictionary has this particular state. With this item, this particular item is gone. Okay, great, I can do that. But DEL is not the only way of doing that. There are so many methods, I mean a lot of methods to do that, but just to compare all these, I'm just giving you the most similarities and differences wherever available. Okay, great. So I have asked you a question in this particular video. Can we concatenate two dictionaries together, particularly with a plus operator? If yes, then we are done. If not, then are there other ways and stuff like so? That's the question. So hope to see you in the next video with more on these data structures. Okay, I asked you a question last time. Can we concatenate this two dictionaries together with a plus operator? So what's your answer? Yes or no? The answer is no. Yeah. So we cannot concatenate them together. We cannot insert another dictionary to this dictionary using a plus operator, because this plus operator is not defined for dictionary. What we can do is we can call an update function, because dictionary is also a set. I mean a set of key value pairs, but at the end of the day it's a set with specialized function, of course. But we can call update functions and insert the whole new dictionary inside dictionary as follows. Yeah, so the answer is using plus operator, no, but there is a way using update method. Great. So next we focus on the copy function. The copy function is available for list, the copy function is available for set, the copy function is available for dictionary. So let's see the need of this copy function. Here I want you to be very careful because that's really important. Let's say we have a list. Let's say that's a list. And by the way, the same goes with set and dictionary as well, whatever I'm going to do with list. Let's say you have a list. Now what you do is you copy the list, or you just make another variable, like you can assign the value of L to another variable L2. What you do is that. Now L2 is this. Now these are two different variables. L is this variable, L2 is this variable. So you might be thinking L2 is separately completely a new thing and L is a new thing. You might be thinking that both are independent. But Python internally manages the data structures, most of the data structures, in a way that, because the data structure is a collection of a lot of data, it is consuming a lot of memory. What it does is, when you assign a variable or data structure to another variable, it does not actually copy all the contents. It does not actually make a new memory and store the contents in this. It actually, this variable also actually points to the same memory as this. And the consequence of that, if you change any value, for example in L2, let's say you change the index 2 value from this, the index 2 value is 4.9, now you're working in L2. Let's say you change this L2 value from 4.9 to, let's 4.9. Let's say you do that. So you might be thinking that this happens in L2. Well, in L2 that has happened. But what it also does is, it does the same thing in L as well. So L also changes. The reason is, L and L2, they both are pointing to this structure in the memory. And whether you approach that structure through L or you approach that structure through L2, you're approaching the same memory anyway. And that is called referencing. I mean, it does not create the data, it actually creates a reference in the memory. It actually creates a new name for the same memory. And both are pointing to or accessing to the same memory. And if you really want the behavior so that L2 becomes different than L, and whatever I do with L2 that should not affect L, then you should call copy function. L2 is L dot copy. Yeah, so that's the function, L dot copy. Now you have L2. Now you do whatever with L2, it will not affect L. So L2, for example, index at index 2, you again say, okay, this is 4.9. So L2 changes. Now L2 changes, but L doesn't change. L doesn't change. L stays the same. Now this has different copy. Same concept go with the set, and same concept go with the dictionary. If you just make another variable s2 and equals to s, then if you change the contents of s2, s will change. If you don't want that, then copy it. Similarly, copy the dictionary. Because the contents of the tuple, they are not changeable, the copy function is not available for tuple. Because even if you assign this t to t2, you can now not change t2 because it is immutable. So having a copy function doesn't make sense in tuple. Great. One more thing regarding slicing. Let's say you have L that's available to you like so. That's L, and let's say you make L3 another list by slicing. Let's say a list from 1 to 5. Let's say. So you start from index 1, which is 3, and you go to 5 by not including 5. This way, the L3 is automatically a copy. It is not a sublist which is referencing. So L3 is a completely new list, a new memory view. If you change the contents in L3, for example, L3 at index 0, it should go from 3 to, let's say, 3. If you change the contents in L3, these change will not reflect in L. So if you do the slicing, slicing picks a copy by default. It does not picks a reference. And that's a huge difference between this list and a NumPy array. And we will see that when we will see a NumPy array, the slicing actually also again refers to the same memory location, and that might be one difference in indexing. Indexing in the whole Python, whenever you do slicing, you get a copy. But in NumPy, when we will see NumPy in detail, in NumPy when you do slicing, you get again a view, not a copy. And if you change in the sliced variant anything, the actual contents also change. And there is a reason to do that. There are efficiency reasons to do that and stuff like so. Again, the .copy function becomes, the copy functions become much more applicable there as well. So you need to know that even if you do slicing in general in Python, in any collection, in any array, in any if you do collection for even for mutable objects like list, you get a copy. But in NumPy array, this particular thing, with a lot of other things, this indexing scheme actually changes with this kind of slicing. Okay, so I end this video here. I mean, you can explore much more functions of list, tuple, set, and dictionary, and what you can do with each of them, and what you, in which scenario, what kind of thing is more suitable for the other. That completely depends upon the problem at hand. But what we can do in what we'll be doing in the next video, we will be seeing some functions of just list, and then I will be just letting you to explore the tuple, set, and dictionary and all their functions on your own, and to see what function or what method is doing what for which kind of data structure. So in the next video, we will be seeing some methods just for list data structure. Hope to see you in the next video. Like in strings, let's explore a lot of functions in list, although in sets and dictionaries and tuples as well, but many more functions are available in list. And by the way, let's see how many things are there in this list. Let's say L dot tab, and tab will open up a lot of things with me for me. Append we know already, clear, copy we know already, count we don't know, count, extend, index, insert, pop, remove, reverse. Some of these functions they make sense by just their name, but let's see one by one. Let's see some of those, what they do. One way to do that is go to internet and see some book or tutorial or something like so. Another way is just write this, apply maybe help function, maybe apply a help function. It may help you how to use that. Great, this help function is great. So append an object method of built-in list instance, append object to end of the list. Oh, it appends an object to the end of the list, which means we may be able to append another list to a list. Maybe. Have we thought about that? The append method just takes one object. Maybe it takes a whole lot of list, but then it may be possible that a list is appended inside another list, and that whole list becomes one element, because list can contain other lists as elements. Well, that's a problem. Yeah. So let's see more functions. Yeah. So let's see clear. Well, what this clear? What is this clear? What it does? Sometimes I use help. Sometimes I use that. Remove all items from the list. Oh my God! If you call the clear, the list is empty. Okay. If you just call clear function on a list will become empty. Be careful. Okay. Great. What else? So let's see. I have this function, maybe pop. What it does? Pop does what? So let's see. So pop removes and returns item at index, default is the last, which means if you also, that's a default value. Remember the default value? So if you call a pop function without an index, it will remove the index, it will delete the last item, and it will give you that, it will return that. Or if you give an index, it will remove that value at that index, and it will, after removing, it will return you that, so you can use it wherever you want. So there are many more functions. For example, you can see all of them one by one. Remove function, for example, reverse like the name suggests. If you call the reverse function, the list will be reversed. Yeah. And remember, we have reversed the list in the following way as well. We have a way of reversing any array this way. So now if you see, the list is again reversed. So I guess both of them are working like so, same. Similarly, you can explore several functions from a set. You go and say add, clear. Clear might be working as same as intersection and update, is disjoint, is a subset of the other. Yeah, add by default or update by default actually take a union. So I'm not seeing update function here. Where is update? Oh, union is there, update is there, which means the list you are seeing is here is not a complete list. You may be writing what are the functions that start from you, so here are they, and several others. Similarly, you can go to dictionary and call for several functions: clear, copy, from, keys, get, items. Oh, that item might be interesting. What is this item? What it does? Oh, it has an error. What? So how can I use this? How can I use this function? Let's see. Oh, this is just an object. It is not a function. I don't know. Let's see again. Or it is not listed anywhere. Oh, it is items, not item. Okay, items. That's a function, maybe. So these are all the items. 23 with this, B with that, new key with that, and so on. Great. So actually, the purpose here is not to tell you each and every function and what it does. It will take a whole lot of time. You can go and explore all these functions. The purpose here is to tell you what kind of data structure has what kind of properties and what are the similarities and differences in between. So if you remember this one slide for list, tuple, set, and dictionary, and some text that is written out above, you'll be having very good knowledge of where to pick what kind of data structure in practice. So in the next video, I'll be actually going to Jupyter Notebook as our style, and I will be coding or solving some problem for you that will involve list, tuple, set, or dictionary, or one of them, or we will be choosing based on problem what kind of data structure is well and what. So we'll be doing that. But before that, I just want to mention that list, tuple, set, or dictionary, they can contain any items inside any kind of type, which means a list can contain another list. A list can contain a set. A list can contain a dictionary. A dictionary can contain a list which itself contains a dictionary. I mean, this is all abstract. This is all abstract. One thing can contain the other. One thing can contain an instance of, I mean, a list can contain multiple lists, and those lists can contain more lists and so on. Before actually going to problem solving, let me give you a flavor of that, how abstract these things are. Let me give you a flavor of that in just in a couple of examples. So in the next video, I'll be giving you a couple of examples based on the abstractness of these data structures, and from the next video we will be doing some problem solving based on that. So next two videos are completely on Jupyter Notebooks. So get ready. Hope to see you in the next video.